Hi, everyone. Thank you for joining us for today's special double feature session. We have two very distinguished speakers today, so I'll take just a moment to briefly intro them and their talks. So first up is David Corbett, Director of Engineering at Pushpay, who will talk about reducing the risk of rapid development and continuous delivery. As Director of Engineering at Pushpay, David is responsible for team leadership and culture, as well as collaborating with stakeholders across the business, contributing towards building a culture of people-focused, teachable, driven simplicity and generosity, which are Pushpay's core values. Our second talk is by Alexei Shpakov, Senior Developer at Jira Frontend at Atlassian, who will talk about testing Hourglass at Jira Frontend. As a senior member at the Jira Frontend team, Alexei's work is focused on making developers' life easier. This covers a lot of areas, ranging from implementing a fast and reliable release pipeline and making the development faster, to maintaining repository in a healthy state and introducing new capabilities used across the repository. So without any further ado, I will turn this over now to our first speaker. David, the stage is yours.
Okay, thank you. So the title of this talk is around reducing the risk of rapid development and continuous delivery. And so basically, I'm going to be talking a bit about the Pushpay's history, our development cycle, and the things that we do that have empowered our team to be autonomous and using multiple tools, but mostly about the culture and the systems that we've developed that help us gain confidence and reduce the risk of what we do, so that we could rapidly grow and scale as a company. I'm David Corbett. I'm the Director of Engineering at Pushpay. I started with Pushpay 5 years ago now, a little bit over, as a senior developer, and I've seen massive growth during this time. So we've gone from just a few customers in that time to massive growth. And our main market is in the US. And there's two things that we do. All right, Pushpay, we facilitate generosity by processing billions of dollars in charitable giving, and that's primarily in the US market. We also enable engagement of our customers with their communities with an apps builder platform, and we publish thousands of apps for our customer base. So as you can understand, there's some pretty big challenges in this. So both in fintech and in app building and doing that at scale brings some pretty big challenges. So I'm going to talk about how we tackle these challenges and how we scaled to where we are today, and being able to reduce the risk by using some of these systems and structures and culture. So for us, what's important is not necessarily the tools, although the tools and the technology does come, but what is important is the culture, the systems and the structure. The tooling and the technology and everything else flows out of that. And you may have heard it said that, you need to put first things first and the rest will follow. And for us, we've found that's really true. But I want to wind back a little bit to when I first started. Story time. Let me tell you about when I first started at Pushpay. I joined 5 years ago, as I said. We were a fairly small team, product and engineering, QA and design, and sales. Everyone, we fitted in the same small office. It was definitely, an exciting place to be, but we were small and everyone could communicate easily and well with each other because we're all right there. And when I first started, actually, I was pretty nervous. I'd been with another company for a little while, and I had a friend at Pushpay, and he invited me to come over and join the team. And I think it was about my third week in, and the then VP of engineering, he asked me, he said, "Hey, David, I hear you've done some work with perceptual diffs or visual validation. Do you want to take on a side mission and trying to get something working here?" at which point I was like, oh, okay, sure. I was super nervous about it, and I really didn't want to screw up my job, right? I just started. I didn't want to make my friend look bad. I was hesitant to take on something and produce even something that perhaps wasn't up to standard. So I was even, trying to discover what the coding standards, what the kind of level of quality was like. And everyone that I'd worked with so far was super smart and really able to think things through at a level that I'd found a little bit challenging, and so I was nervous, and I didn't want to screw up. But really, even though I had that massive imposter syndrome, and I'd come into an environment where there was a lot of people who are excellent at what they did technically, I actually came into an environment or an organization where we had great people who were technically strong, but they also understood some key principles, some key things that really sets everyone up for success. And I want to talk to you about those things first, and then I'll talk about how we use the tooling that will facilitate or automate those customs and facilitate that success. So I'm going to talk to you about outcomes, and defining outcomes, thinking in systems, then following on from that, technology, and even getting to visual validation, how we've used that and how that fits into our product. But first, outcomes. So, outcomes, what does it mean to start with outcomes? It means to start with the end in mind. What do we want to achieve, not necessarily what is the thing just in front of me that's a point of friction or a point of pain, but what do we really want to achieve? What is the outcome? And why do we need to do this? So we need to start with the why, the problem, the friction or the behavior that needs to change, and define what our outcomes we want, but not just the outcomes, but also the principles by which it's acceptable to get those outcomes. So, I can achieve an outcome of going really fast, but I could, as part of that, maybe I want to deploy into my production environment 15 times a day. And it's like, sure, you can get that outcome many different ways. What are the principles by which you're going to operate that are not negotiable as well? So for us, some of those principles were really key in defining how we achieve the outcomes and how we build our culture so that we're successful in not just achieving the outcomes, but the outcomes that we actually really want. So I want to talk to you about what's important to our customers and their success. And for us, like I mentioned at the beginning, we facilitate donations between a person who wants to give money and a charitable organization, usually a church, sometimes a school, or a charity that wants to receive that money. And so what's important to us and our customers and their users is to be able to never miss a donation, right? So our customers want to receive that money, but also when a person is feeling generous and they want to be able to give, they don't want anything that gets in the way. They want the least amount of friction possible to enable them to be generous at any time, right? So anytime, night or day that they feel like or that they're prompted to give, they need to be able to give. So for us, that means the most user-friendly, the most reliable system that we could build. So that means low risk, right? But we also have some engineering outcomes that we want. We want to scale our team. We had some VC funding at that time, and we were growing our team. We were scaling our processes, and we had so many different kind of features and things that we wanted to build out a solution. Going from that startup phase where you have a very minimal product to begin with, and then adding on all of those valuable features that add value to your product. And so we wanted to build this with low friction as well, and we wanted to be able to scale our team and our processes. And so we needed our developers and our engineers to be able to own their own code, own their whatever they're building. It wasn't just code, right? For the entire software development lifecycle. So that's everything from being involved in the conversation about the feature definition, why are we building this, getting an understanding of the context, what it means to the customer, what the customer problem was, through to operating it in our environment, in the production environment. We also needed to be able to deploy more frequently with higher confidence and quality and zero downtime. And so how do you do that? You have these two things which are seemingly at opposition to each other, right? We want low risk, but we want to be able to make a lot of change at the same time. So how do you hold these things which are in tension with one another? Well, at first, we used to do things that were in odds with the outcomes that we needed. We had a single person who would do all of the code review, and they would actually ship all the code as well. And so, like, everyone would, you'd work on your problem, you'd code up your solution, you go, hey, Alex, I want to ship this code. I think it's ready. Maybe I've tested it. Like, hand it over. It's yours now. That has a couple of problems, right? One, it just does not scale. You cannot do that with you can do that with a small team of maybe 3 or 4 people, but you cannot do that with a team that's growing, upwards of 50, 60 people. That does not scale. And also, like, it's not a fun job for one person to do and that be their sole job, right? And you've got that key person risk as well. So what happens if they're off sick or if they're on holiday or anything like that? So we decided to scale this by rotating that responsibility around the people, around each of the teams. And so at that time, we had just formed teams of 2 people each that were ramping up and hiring and filling out those teams to be more people and shipping all that code to production. But even that, we were like, well, there's hidden queues. There's people who are wanting to ship things, then they're holding on to it because it's taking too long to get things into production. Rotating this responsibility around meant that one person was not able to work for this week that they were on the rotation on anything else apart from shipping code. And then they had shipping the code had to be against their time frame. So in effect, we had a system which was okay for when we were a startup, when we were 2 or 3 people, and it didn't matter that much. But now that system was broken for the size and the kind of company that we were rapidly becoming. So we looked at our system and we started diagnosing what it was holding us back from the outcome. So we didn't just go, oh, that's obvious, we need to fix that. But we took a step back and started to look at really what are the wider outcomes that we want to achieve, and how do we really go after those things? How do we go after like rapid deployment to being able to get changes in, but low risk? How do we automate our habits and our systems as well, that would really help us to move fast? So we decided that we needed to take not a localized thinking or problem solving, but elevate it to that high level. So what was the best problem to be solved at the time? So you need to take that kind of broad, high level view before going deep and discussing, oh, okay, we can optimize this particular part. So, in data science, they call this, local minima versus the global minima problem. And it's a common problem that we all face, right? We also decided that we were growing as a team, so communication lines had to change as well. So, going from that kind of, well, we're only 2 or 3 people in a room, we can all talk to each other easily and be aligned with what's going on. We need to start to think about how communication works and as we get bigger. And we needed to get buy-in from a wider team of people and scale our thinking beyond those few people. So that leads me to systems. And I love systems. So systems, like, how do you get what you want? How do you get the outcomes? You have to recognize, I guess, that you've got systems and structures, either intentionally or unintentionally. But those systems are what produce the outcomes you get. So we were getting outcomes, but the outcomes that we were getting were not necessarily aligned with the outcomes that we wanted. To get better outcomes, there are two things that you can change, right? You can either change the inputs or you can change the systems. And one of the things that we realized early on is that our culture is a system, right? Your culture is actually your organization habits, and a habit is an automated system. So your culture is that organization habits, the way that you operate, the kind of written rules sometimes about how you operate, what you value, the way that you do things. And so we took a look at this and took a look around some other great companies like Etsy and other companies who were doing some good things at the time, and started to really look at what does our culture need to be, and how do we intentionally change this? How do we intentionally build the habits that we need to produce the outcomes that we wanted? So the habit loop consists of a cue or an action, a cue, so something that kicks off that system or that habit or that action, and it works out that process, and then there's a reward at the end. Therefore, it's important to look for the cues that already exist that can trigger certain automated actions or habits, and make sure you intentionally design the system or habit that runs when a cue is heard. So let me tell you about an organizational habit that we have and why we started to get visual validation into our production deployment pipeline first, not into a development or test system or a side project. So one of our habits that we have, our organizational habits, is around new people when they join. We really like them to be able to ship some code, something of value, into our production environment within the first week of working, and ideally, within the first couple of days. So usually it's a small piece of work, a copy change or something that is fairly low risk and fairly small in size. And the reason that we do this is because they get introduced to our shipping process, the habit, the system, from the very beginning. And when they ship their first pull request into production, we celebrate, right? We clap, we cheer, and like it goes into we've got the Slack channel called Clapsplain, because we're a big organization now, and people will join in on the clapping, and they'll be like, why are we clapping? We're celebrating something, but what is it? So we have to go to this channel to really understand, oh, okay, cool, we're celebrating this thing. That's awesome. And that has obviously worked really well for us as we've moved into this time, during COVID, and we're everyone's remote now as well, and so that kind of celebration has still happened, even though we're all remote. So yeah, why is this important? Well, essentially, we're intentionally designing the habit around this automated system, like where we hooked into an existing queue, and the reward for that habit, was there as well. So the queue was the starting of the shipping process for us. Like, the reward was deploying something into production and getting that sense of accomplishment and the celebration. That's why it's so important for us, for the people who wrote the code, to deploy their own work. We don't hand that over to another team to do it, but it's up to the person who wrote that to be able to deploy it. And they also, they get the reward, but they also get to keep the ownership of it, which means that they look after it in our production systems, and they will be looking at metrics and really understanding how that code operates in our production environment, how our customers use it long after they have shipped it. So we intentionally build a culture of learning, a culture of sharing that learning and celebrating that learning, which includes our failures that lead to those learnings. So a big part of that is blameless postmortems. I'm not going to go into much detail on that. You can find plenty of talks around about blameless postmortems and the culture around that and why it's important. But that's a big part of it for us, but it's only a part of it, right? So we do many other things that really build that culture of learning, because there are so many decisions that we make where we don't have full context, but we get some learning of it. But how often do we lose that learning over time, or we don't share it? And so each person has to go through the pain of being able to learn that thing again and again. So what we really want to do is to be able to capture the learning. We want to share that learning, and we share that in multiple different ways. We do brain food sessions where somebody will get up and talk about a problem that they've faced, a challenge, maybe a failure, and what they've learned out of it. We do, like I said, blameless postmortems where there's an artifact, and we share those. We share them wide. We even share them with our board of directors. And like I said, we celebrate our learning. So we celebrate, deploys into production, but we also celebrate, somebody having their first postmortem, that kind of thing as well. How else, what else about our culture really is a system that helps us get the outcomes that we need? So there's a few models about how you can build an engineering team and how you go through that growth and you scale. One of those is by managing carefully all the tasks that happen. The other way is really to foster that autonomy or autonomous workplace. And for us, we decided that we were going to build a framework of autonomy, which is not independence. So independence is like, anyone can do whatever they like, and you end up with chaos because everyone's pulling in different directions or just doing what they think works best. Autonomy for us is where we've got a framework, a set of guidelines and principles by which we operate, the values, you could even call them, that enable good outcomes. But it's really up to people to work within that framework to get the outcomes that they need. So we don't necessarily specify you must use this type of tooling or this kind of thing, but we have a framework by which people can make good decisions. And some of the things in this framework or these principles have really come out of the learnings that we've had as an organization, some of the postmortems that have happened as well. So when we talk about things such as, we have a principle or a value, which is we don't do things alone. That includes everything from interviewing and our interviewing loop through to making sure that every pull request is code reviewed. Every pull request there's a discussion with a QA or a product manager about the value of it and what's happening. And if we need to make changes to data in our production systems, we're definitely co-piloting those changes and doing that as safely as we can, because we don't want, it's easy to make a mistake. So how do we reduce that kind of risk during that at the same time? But we also want to empower people to own the full software development life cycle with help, with guidance, and with those defined principles, which makes it easy and frictionless for people to fall into that pit of success, right? Not only do we define these principles or habits and values, we want to make them frictionless. We want to automate them as much as possible. So we've ended up with bots galore. We use Slack quite heavily, and we have bots within Slack which help us do everything from shipping code, remembering to finish off post-mortem mitigations, through to reminding us to celebrate and to thank people and things like that. So I'm thinking of giving a talk about all the bots that we have at some point, their purpose, and even, you know, when bots go wrong, when you have too much of a good thing, can be too much sometimes as well. But yeah, like that within that framework of autonomy, like anyone can change something. We encourage autonomy and distributed ownership. We encourage people to make our systems better, that it's not any one person's job to do this, but it's up to everyone to improve our ecosystem. And you know, there are certain habits or culture that we have that run automatically when somebody wants to make a change, such as making sure that they socialize the ideas, that the proposed changes aren't surprises, and that they can be refined before they get implemented. We have approach reviews for when we're making like architectural type decisions, which is, it's a lightweight discussion document. And what's important about this is the discussion on the proposed approach and what we're doing to solve that. It captures the thinking about why this approach, it invites opinion and others to comment on it. And typically, you know, somebody would bring that kind of approach review document to a guild or as part of a socialization aspect. So these are the principles, or these are the systems that we have in place that really help us to get good outcomes. Now, those outcomes that I talked about at the beginning, you know, of getting fast with low friction is really what we wanted to do. So you can see how culture, which is your organization's habits or automated systems, is very important to getting the outcomes that you want. Yeah, let me talk for a little minute about quality habits. So for us, you know, we have QAs within our teams, but the QAs are not testers. They do not own quality as such. Everyone owns quality, but you know, like ultimately the developers, the QAs are there to facilitate and to really help people to think about quality in ways that perhaps they don't. So because the you know, owning of the entire software development lifecycle for an engineer is a really big ask, right? Like you're asking them to keep monitoring what's going on in the production environment, about all the things that they've written, as well as thinking about upcoming features that they need to design and what they're building at the moment. They need assistance to do this. So we need not only good systems and structures in place, but we need other people to help prompt the right kinds of thinking. And so for us, a QA is a quality champion within a team. They're there to help people think about all of the aspects of quality, not just testing functional requirements. So when we think about quality, you know, we think about scale, performance, but we're also thinking about things like metrics, logs, alerts. Like, how do we know when something goes wrong in our system? Ideally, before a customer or anyone else tells us. We want that automated and even self-healing if it can. You know, those are aspects of quality that we're really interested. How can we improve or keep an eye on our service health over time? You know, and even going earlier into the development cycle, how can we risk storm, do pre-mortems and so on about what potentially could go wrong and try and mitigate those things before they actually happen. So quality is such an important part of our life cycle, right? I'm going to talk, briefly about our shipping system, but I don't want to go into too much detail here. As you can see, like, this is an example of one way that we ship one of our pipelines. We have many. We deploy multiple times. I don't know, maybe 20 or 30 times a day. We don't have a particularly large team. Like, we're not in the hundreds of developers. We're still in the tens. So it's there's a lot of different kind of services that we operate, but a part of what we've done over time is to refine our processes and refine our systems. And as you can see here, like, we've got these bots like C3PR, which is our shipping protocol droid that really helps us to ship software, make sure that we're going through our stages correctly. It's automating some of that kind of having to think about things and making sure that that process is followed as we've defined it, or as the team has defined it for their particular shipping. We have, some fun things injected into there as well, like, our Mario leveling up coins as part of, passing each stage of the build process, do the test pass and things like that. So some little kind of celebration or thing, a bit of fun injected into this as well. And so like there's a lot of things that happen as part of this whole process. And one of the things that we do is visual testing. Visual testing is an important part of our deployment cycle, making sure what we're presenting to our customers is high quality and is not regressing in some kind of change. And so we run visual tests. We run a lot of them. We have I think it's in the order of 20,000 visual validations a day, and this is just across not everything, but the main parts of our most customer-facing parts of our system as well. So how do we do this, and how do we do it differently? Like, we inject the state or the data into a view, and then we do a visual diff or a snapshot of that view. At that point in time, and we compare it, then it gets compared against the baseline, right? We have a mock data injection for MVC, like Razor views, and we use Storybook for React components and pages. And all of this is baked into our deployment pipeline. So we have to approve changes, or we have to go back and go, oh, actually, no, this is broken. We need to do something about this. We can't just leave things in a broken state. It requires some kind of action, and it requires us to fix anything that is causing friction, such as the flaky test or something like that as well. So there's some really nice benefits by making sure you're codifying the behavior that you want and the outcome of the system. Really getting what you want. I can, hang on, I think I've got, tools. So the tools are the things that help you build and maintain and run your system. So like I said, we use visual validation as part of our process, but really the visual validation is a tool that fits into our overall system that really gets us the outcome. And it's this kind of thinking that's really made this a place at Pushpay that has meant that we've had high quality, like rapid deployment, being able to really run really fast, but actually pretty safe. And it's that kind of thinking that we need to bring at every kind of level of our organization, through from thinking about how we're structuring our teams and the kind of products and what products and features that we're building across the board, through to individual teams thinking about like, how is it we're going to agree to work together? What are the habits that we want? What are the outcomes that we want? And how we're going to automate those things. This is just a slide to show some test execution for visual validations over the last kind of 30 days. And as you can see, there are some times where we have quite a few changes that happen. So these are unresolved changes. But as you can see, the next kind of things that follow this, that how we read this graph is like this. There's not a lot of unresolved changes going from build to build, which means that people are taking action, which is what we want, right? So they're either accepting those because they're intentional changes as part of that deployment, or they're going back and fixing something up as it went wrong. Cool. That's me. Is there any questions?
Yes, we do have some questions. So first of all, it's a question that we get quite a lot from from people for people in your position. So you talked a lot about the culture and the fact that you even mentioned it in passing that you don't do things alone, such as hiring and interviewing people. And one of the questions that we got is how do you hire? What are your prerequisite for hiring QA and developers in order to fit into that culture?
Yeah. So our hiring loop is intentionally designed. It's not short, but we try and get through it quite quickly. We put a lot of effort into hiring because hiring people is really, really important, right? To get the outcomes that you want. Hiring good people. We don't look throughout our hiring process whether for knowledge, but we're looking for ability to reason through and problem solve and things like that. So being able to test those kind of things is a little bit hard. So we like to see people in action. So our hiring loop consists of meeting up for a coffee with people and just talking about our culture and our company and how we do things. Hiring is more than a one-way process. We're not just interviewing people who want to come work for us, because we've got to fill a position, but they need to be making a good decision for them coming to work for us. So we want to be able to provide like that information back and that kind of ability for them to interview us as much as we interview them. So really what the first stage around having a coffee chat is just talk about a culture, talk about the way that we do things, really show people what we do and if this will fit with what they want or otherwise. Then we do like a technical screen, and our technical screen, as I said before, is really about the way that people think, not about what they know. And so we're aimed at, at all levels. Can you problem solve? If you don't know something, that's good, because none of us know things all the time, right? Like we're testing for things like humility, ability to reason through problems and have a good discussion with us. So when you don't know something and we feed some information, like are you able to join the dots and have that kind of conversation that leads to a solution, because that's what we do every day, right? Nobody comes into work knowing exactly what you're going to do. There's a lot of collaboration and conversation that happens to produce solutions. And then the final part of our interview process is coming in for a day. And so we have a day in the life of exercise, and that can be remote as well, where we give people a problem to work on, something that we've actually is a real problem, either in our code base or like if it's a product management role or something that we wanted investigating, or like a real problem that we've had in the past that we've solved in some kind of way, and see how people are thinking about those. It also gives them a really good chance to meet the team, to interact with a lot of people that we've got here and that kind of thing. So that's kind of our hiring loop, and it's intentionally designed that way to be a good two-way process. Yeah.
Wonderful. So we got a lot of questions about the division of labor between the developers and the QA, especially around what you said about the QA are not testers. So people were asking about, so what are they like? What do they do? What tools do they use? What does their day look like? If you could expand a little bit on that.
Yeah, so our QAs, they spend some time working with developers and talking about solution, like risk. They talk about like even, do you have enough unit tests to cover these scenarios? Like what is, and they would work with them to define like a testing plan. So making sure that we've got a plan that could be executed by anyone. It doesn't have to be executed by our QA. But there has to be like, in a test plan that kind of happens as soon as a developer is picking up work, really. So at that point, there's a conversation that happens, making sure that we're aligned on what the outcome of this piece of work should be. And then, developing a plan in collaboration with them. We do have QAs writing code, automated tests. Maybe they're writing the automated tests as part of this feature or this bit of code that the developer's writing. So they might, decide on what needs to happen there. But also they might be like producing documentation or dashboards or taking a look at service health. We also have our QAs involved in our support rotations as well. So they're, looking at incoming support tickets, triaging them, sometimes even, working closely with a developer or solving them themselves if they can. So yeah, the outcome is to own quality. How you go about and do that is a little bit individual, although a lot of what they do does look similar, but it really does depend on the team. Yeah.
Okay, so we have a follow-up question on that. So people are asking, would you say that the QAs at Pushpay are more governance and monitoring rather than testers? And also they want to know if they write code, are they software developers, engineers in tests or not?
Governance, maybe not. I would say they're more like quality coaches. So for us, like I think we know that engineers can tend to fall into a trap of like a way of thinking that's not necessarily from a user's perspective, right? Whereas QAs are really good at thinking about what users will do and how they might break a system, that kind of thing. So there's an aspect of coaching to the role, but more than that, it's definitely thinking about quality outcomes, and those quality outcomes are more than just testing functional or even performance or some of those non-functional requirements. There's a lot more that goes into it. It's helping us to get the highest quality out of our system as possible, and that's the role. And so there's a lot of facilitation, discussion, risk storming, as I said, sometimes even like helping developers write up timelines for postmortems, or they might facilitate, or take on certain roles outside of that kind of core thing. Sorry, what was the second part of that question?
They wanted to know if the QAs actually write code. Are they software developers in test?
So they do write some code, yes. So automation is definitely a part of what they do. So a lot of them would be writing automated tests, framework, but like we'll have developers doing that as well, so that they work in conjunction or work together on those kind of things. So yeah.
Okay, but we are out of time, but there is one last question that I do want to get to. So you were talking a lot about the culture of learning and sharing, and it sounds like there's a lot of tribal knowledge going on there. How do you handle documentation and knowledge sharing? Because obviously you do have new people coming in, some people leaving. So how do you make sure that all that, or maybe the point is for all that to remain as a culture of sharing, but not of documentation, or does it have some aspects of knowledge sharing and documentation?
Good question. At a certain point, or when you get to a certain size, you have to go beyond tribal knowledge, right, to be able to kind of scale and to capture that. So what we try and automate or capture as much of that kind of the habits and the principles as possible, and automate that into systems. So we have a lot of bots, for example, that help us to solidify that culture and help us to do things that way. We also we have all hands that we run every month, and we talk about culture a lot. So we facilitate that through discussion. We talk about examples in that. We might dive into what are our engineering principles by which we operate, and give examples and talk through those. We do a lot of like lunch and learns and sharing, brain food sessions, those kind of things that also help facilitate like sharing. So there's some ceremonies or meetings that go with that, but yeah, it's codifying as well, and yes, documentation is really important. So for our values or for our principles, anyone should be able to go and look those up and be able to like dive into those and see some examples for sure.
That's wonderful. Okay, so we are out of time for your talk. David, thank you so much for joining us today and for this in-depth presentation. I really appreciate it. Thank you so much. And now I think that we will turn over to Alexei. So our second talk will be by Alexei Shpakov from Atlassian, who will talk about the testing Hourglass at Jira Frontend. So Alexei, over to you.
Hi, good day, everyone. My name is Alexei Shpakov, and I work in Jira Frontend platform team. We are responsible for builds, deployments, dev experience, and repository maintenance. Today, I'm going to talk about testing in Jira Frontend. Testing pyramid is a metaphor coined by Mike Kong. It acknowledges the existence of different types of tests and provides a suggestion what could be a healthy ratio between the groups. The pyramid starts with unit tests and suggests this should be the majority of your tests. These tests focus on testing small units comprising the application. On the next level, you can find integration tests, which test that separate units work together properly. At the top, you can find end-to-end tests, which test application as a whole. The area of pyramid stands for the number of tests. That is, the metaphor suggests you want to have a lot of unit tests, fewer integration tests, and just a handful of end-to-end tests. These three categories of tests, however, differ on several parameters. Unit tests are by far the simplest ones. They are focused on a particular functionality and mock any dependencies. This allows us to guarantee we are testing the code at hand and nothing else. This also means we'll need to modify the unit test only when corresponding functionality changes. As we mock all the dependencies, unit tests are quite stable and fast to run. As integration tests focus on interaction or integration of the groups of units, they usually include at least two not mocked units and run different integration scenarios between them. As the number of units grows, we get more tests involving a given piece of code. Here, we need to account for multiple units at once, which makes integration tests more complicated. Subsequently, as any of the units change, we may need to adjust all the tests the unit is involved in. With many real non-mock dependencies, integration tests are also more prone to breakages and take more time to run. End-to-end tests work with the whole application and aim to replicate real user scenarios. This means even before you write the first test, you need to deploy the application. This could sometimes be a huge effort on its own. If your service is stateful, you may need to pre-populate the database before running some of the tests. The majority of user scenarios interact with a big number of application pieces. This means whenever one of them is slightly modified, you may need to adjust multiple end-to-end tests. This makes end-to-end tests high maintenance and fragile. On top of that, as you are testing a real application, the tests are susceptible to network latency and other real-world inconsistencies, which makes them even more fragile and slow. Testing pyramid is a great rule of thumb that can help structure your testing strategy. Once you introduce different types of tests with decent application coverage, the quality will certainly go up. But is it sufficient? Is it good enough in a long-term perspective? As the web applications become more complicated and get more customers, even with a properly implemented testing strategy, it becomes increasingly hard to guarantee that all the possible combinations of inputs are properly tested. At that stage, you will realize that your customers unknowingly have become manual testers for your product. In fact, some of them might even create tickets in your public ticketing system. This is really bad customer service. If you were strictly following the testing pyramid approach, you would start heavily investing in adding a lot more end-to-end tests in order to account for all sorts of unusual combinations of inputs you can find in production. The issue is that in production, we're dealing with an exponential number of those combinations. Subsequently, you will need to have an exponential number of end-to-end tests. These tests require a lot of effort to write, to maintain, and they are slow and fragile. As a result, developers will have to spend a lot of their time just maintaining these tests instead of writing new features. Our releases will suffer as well because they will be delayed because of the amount of time it takes to run all those tests. Let's go back and recall what testing is about. If you ask Google, you will get the following definition. To test means take measures to check the quality, performance, or reliability of something, especially before putting it into widespread use or practice. The word widespread is important here. It is easy to assume that testing can only be performed before the code gets deployed to production. However, testing your code in production is as important as testing it before the deployment. At Atlassian, we acknowledge that having a good testing pyramid is not good enough to deliver a high quality product to our customers. We build on top of this concept and introduce an hourglass of testing. The bottom part of the hourglass is the testing pyramid as you know it. Its peak is a released deployment, and the inverted triangle on top of that is post-deployment verifications, monitoring, and logging in production. Let's have a closer look how different parts of the hourglass are implemented in Jira Frontend. The very first level of testing pyramid we have is type checking. Compiled languages get it for granted. However, as we use JavaScript, we have to add type checking separately. We use Flow for type checking. In an ideal case scenario, you want your whole code base to be thoroughly typed, including your dependencies. Unfortunately, this may not always be possible. Multiple researchers prove that using typed flavors of JavaScript decreases the number of bugs in production. However, it may still be a hard sell for management. Instead of pushing for 100% type coverage, we introduced an ESLint rule that forces every new file added into the code base to be typed. That allows us to enforce coverage of the relevant code. The new releases of Flow frequently bring breaking changes. When we bump it, we usually add ignore comments to existing violations and create tickets for teams to follow up. This forces all the new code to be compliant with a new version of Flow from day one and delegates fixing existing issues to the code owners. For the dependencies, we are using Flow typed. It is a community-driven project to introduce Flow type definitions for the libraries that don't have them. Unfortunately, not all dependencies have their types available via Flow typed. We implemented a separate tool to convert TypeScript type definitions, if they are available, into Flow. It is not perfect because Flow and TypeScript do not map one perfectly to each other, but it's still quite helpful. On the second level of pyramid, we find our unit tests. Right now, we're using Jest and Enzyme for unit tests, and the whole code base is written in React. One of the biggest issues with any kind of tests in general is flakiness. There are several factors that could contribute to it in JavaScript code. The most frequent one is JavaScript timers. It is crucial to mock all timers. We're talking about set timer or set timeout, set interval or set timeout. This makes tests more consistent and faster to execute. Another less frequent issue is hard-coded year or month or time zone. In this case, a test resembles a time bomb. It works until you are hitting a particular date, and then it stops working and breaks all branch builds and master. A separate type of tests is snapshot tests. This is a great feature that allows comparing big objects in one go. Unfortunately, it is quite frequently abused by the developers. Whenever the snapshot test fails, they oftentimes just update the snapshot without even checking them. This is really bad practice. If possible, it is really good idea to test for specific features of the object instead of using the snapshot and rely on snapshot testing as the last resort only. We have adjusted just environment to throw errors every time console methods are used. Based on our experience, whenever console methods are invoked, this is either debug code that should not be committed into production, a legitimate error that should be fixed, or a suggestion to improve the code. For instance, if some methods are obsolete and should be replaced with some other methods. In all three cases, there's usually a way to fix the code, which will improve its quality. In rare cases, when the console usage is expected, developers can simply mock it out. We have zero tolerance for flaky unit tests. Whenever the test is flaky, it is removed straight away, and the owners are responsible to fix the test and reintroduce it. Right now, this is done manually, but we are exploring the means of automated flakiness detection and quarantining the flaky tests. There's a lot of different types of integration tests one can run. During integration tests, the goal is to test how well different parts of system work together. If a test is no longer a unit test, but not yet an end-to-end test, it is probably fitting the category of integration tests. In Jira Frontend, we have three types of integration tests: Cypress tests, visual regression tests, and packed tests. Cypress library allows us to use browsers in the tests. Storybook is another library that allows us to render frontend components in isolation. We render high-level component storybooks, mock network requests, and interact with them via Cypress. The fact that we don't have network calls and the storybooks are served locally decreases the latency and makes the tests a lot more stable. On top of that, Cypress provides a possibility to retry flaky tests out of the box. Although it's great to have retries available, and that means that you'll have a lot fewer red builds, we're still masking flaky tests. In order to fix that, every time there is a retry, we'll send a Slack notification to the owners of the test and ask them to fix the tests. We use visual regression testing on top of storybooks. Similar to Cypress tests, we mount components in isolation and take their snapshots. It is crucial to have visual regression testing flake-free. To achieve that, we're running visual regression tests a couple of times. The first time, we perform snapshot comparison against master baseline. This is a normal VR testing people are familiar with, where you have the same component before the changes, after the changes, and you're comparing them together. Afterward, we run VR tests 2 more times. This time, we're comparing the results against the branch baseline. As the input is the same, we expect to get absolutely no differences. If there are any visual differences in this case, it means we have some flaky visual regression tests, and we break those tests. To further decrease the amount of flaky visual regression tests, we're stopping CSS animations, and we're mocking the date for all the stories we run visual regression testing for. We introduced visual regression tests quite recently. As developers opting more components into visual regression testing, you get diminishing returns and testing time increases. Right now, we're introducing tests for high-level components first, and gradually add low-level stories whenever it makes sense. The goal of contract tests is to ensure the backend does not introduce the API changes that would break consumers. And at the same time, that consumers do not have unreasonable expectations for the API providers. We're using a library called Packed for contract testing. We run a separate service called Packed Broker. Every consumer of the API, like Jira Frontend, for instance, uploads their expectations to Packed Broker. Whenever a new version of API is published, it is validated by Packed Broker against all the consumers. This allows us to confirm it does not introduce breaking changes. Once validation passes, Swagger definition for the API gets uploaded to the same Packed Broker. Similarly, whenever consumers upload their expectations, we are checking that they match the existing API uploaded to the Packed Broker. This ensures the contract stays intact. Something we learned the hard way is that we must both verify and upload consumer expectations as a part of the deployment. Originally, we were running pack tests as a part of the build verification and uploaded consumer expectations as a part of the deployment. There could be up to 20 to 30 minutes gap between the time we run pack tests and the time we actually deploy them. If the API producers upload breaking changes during this period of time, it could potentially produce a deadlock. That is, we won't be able to upload our packed expectations because they are breaking, and producers will no longer be able to upload new API definitions on their side because we have uploaded our breaking expectations. As a result of this incident, we are running pack tests twice, as a part of the build and as a part of the deployment, just before we deploy pack tests to pack broker. End-to-end tests are the upper part of the pyramid. This means you want a few of them. In Jira Frontend, we used to have a lot of end-to-end tests and struggled a lot with their flakiness and maintenance burden. Another issue we had with end-to-end tests is the feature delivery. We use feature flags to deliver features to production. Oftentimes, feature flags for test environment do not match those of production environment. As a result, we decided to stop writing end-to-end tests going forward and rely on post-deployment verification instead. The middle point of testing Hourglass is the application release. No matter how good your tests are, things will break in production. The priorities here are to detect the issue as fast as possible, ideally before your customers find it out, to decrease the impact so that the fewer customers are getting impacted by the issue, and mitigate the issue as soon as possible. Let's see how Jira Frontend release process helps with it. Feature toggles or feature flags is a technique that allows developers to modify application behavior without modifying the code. The idea is to introduce a new behavior within an if statement and pass the argument to the if statement in runtime. For example, we can use a third-party service that will inject true or false for a given flag in runtime. Based on this value, we'll execute old code or new code. Every feature delivered to production is expected to be hidden behind the feature flag. That means the exact time a new version hits production is usually irrelevant for feature delivery. Developers use a third-party service to toggle the feature flags that guard their new functionality. This allows developers to control their rollout schedule. In Jira, we expect every new feature flag to have a corresponding feature flag delivery Jira ticket. The ticket contains metadata about the feature, like feature owner, expected rollout schedule, how the feature is monitored, what could go wrong, etc. This allows any other person unfamiliar with the feature to analyze if the feature works well. Additionally, this forces developers to figure out what is their monitoring strategy, how they're going to figure out if the feature works well to begin with. And that makes it so that developers are more confident with their feature delivery. This brings us to another point. In an application with hundreds and hundreds of enabled feature flags, it is important to track feature flag status change. In case of an incident, this will allow to pinpoint suspicious feature flag changes. And associated feature delivery ticket will give the context needed to tell if the feature flag change could be causing an incident. While feature flags are great at de-risking feature delivery, in the long run, they increase the amount of dead code and make the code base harder to reason about. It is crucially important to clean up feature flags when they have been successfully rolled out. Once again, we'll leverage metadata available on feature delivery tickets to identify the feature flag owner, and ping them about cleaning up the feature flag once it has been enabled for 100% of production for a long period of time. However, certain features may not be feature flagged. Some of the commonly mentioned changes that could not be covered by feature flags include build configuration changes and dependency upgrades. Sometimes developers may forget to use the feature flag to deliver a new functionality. These changes have significant risks associated with them. The first customers to receive a new version of Jira Cloud are Atlassian employees. We use Jira for our day-to-day activities, and it is usually quite obvious if some critical functionality is not working well. Once someone notices a bug, they can create a ticket with priority blocker in a specific Jira project. The presence of this ticket will hold any release promotions to production and will allow us to avoid any potential customer impact. Blockers are quite bad for continuous delivery. They lead to piling up of the changes. Once there is an active blocker, it becomes the priority to resolve it as fast as possible. In order to further mitigate deployment risks, we introduced release soaking and canaries. In the case of Jira Frontend, we have one staging environment and 3 production environments. In every production environment, we have canary instances. Those canary instances are owned by Atlassian employees, and they are used for active monitoring. This allows us to identify the issues before we even deploy them to corresponding production environments. Whenever we deploy a release, we deploy it to the current environment and the next environment's canary instance. At first, release gets deployed to staging environment for dogfooding. In an hour, staging environment for dogfooding and the next production environment's canary instance. After soaking for 1 hour, we automatically promote release to the first production environment and also to the next production environment's canary instance. In total, it takes about 3 hours to complete the rollout of a particular release to all production environments. We currently release 6 times a day during work days. Frequent releases allow us to keep the amount of changes delivered to production in every release low. This results in a lower risk of breaking production. Oftentimes, in conversations with quality engineers and SREs, we talk about production configuration as something we can use to write integration tests and end-to-end tests against. This sounds reasonable. If we take production set of feature flags and apply it to the latest coding master, we will probably get the behavior our customers get. This should allow us to run all the test suites from testing pyramid and assess the quality even before we deploy to production. Production, however, is a lot more diverse. As mentioned, we are releasing up to 6 times a day, and every release takes up to 3 hours to go through different stages. This means at any given moment of time, there are at least 3 different versions of Jira run by the customers. Usually, we observe more versions because a lot of people don't reload their pages once they open it, and Jira Frontend happens to be an SPA application. That means unless you reload the page, you're not going to get a new version of it. The behavior of Frontend also depends on the state of feature flags for a given Jira instance. There isn't a single production version of feature flags. In fact, we have hundreds of feature flags released independently by different developers in parallel. Jira Frontend is developed and deployed independently of the backend. As a result, backend has its own release schedule and its own set of feature flags. So even if we find 2 instances of Jira having 2 identical versions of Jira Frontend and 2 identical sets of feature flags applied to them, they could still have different backend and behave differently. The idea behind active monitoring is to simulate user behavior and determine potential issues. PDV stands for post-deployment verification, that is, testing done right after the deployment. We have a separate monitoring tool that runs Cypress tests on given production instances. These are same old end-to-end tests we avoided before deployment. Let's review the differences and why it makes sense. We use production instances to run the tests. This means we're using the latest feature flags values available for the corresponding environment. Why do we call it monitoring and not testing? These tests run non-stop 24/7. That means whenever there is a feature flag change which breaks production, we will get notified about it straight away. The monitoring system allows us to configure the failure rate threshold. For instance, we can issue an alert if the test has been failing continuously for the last 10 minutes. This allows us to significantly decrease the amount of false positives. On the other hand, this kind of monitoring suffers from the same issues end-to-end tests do. They have high maintenance costs, and we still need to make sure that we configure production instances with all the data beforehand. Due to that, we use them sparingly to monitor the most critical parts of our application. For instance, in case of Jira Frontend, that could be issue creation functionality or boards functionality. The second level of the upper part of the hourglass is monitoring, or passive monitoring. Monitoring is used to alert developers in case something goes wrong in production. It is of extreme importance to have reliable monitoring, that is, no or close to no false positives. This could be achieved by comparing against historical data and monitoring the rate of change of the parameter instead of the absolute values. In general, it is better to fire an alert 5 minutes later than fire a false one. Yet sometimes they may not be good enough. An example could be a national holiday in one of your largest markets. These are some things that you get better at by iterating. Once the alerts are configured, they should also be prioritized. This will help people better understand the urgency behind the particular alerts. For every alert, there should be a runbook. A runbook provides a detailed list of steps which will help mitigate a particular alert. An alert is a stressful situation, and having a runbook handy helps a lot, especially if you're being paged at 3 AM in the morning. An excellent idea is to put a link to the corresponding runbook into alert notification message. Wargame is an exercise we run when we come up with possible failure scenarios. The goal of the wargame is to walk through every scenario and define every possible failure scenario and define what we expect to see in terms of monitoring and what will be the expected response. Wargame helps to identify gaps in our monitoring and runbooks. After coming up with scenarios, it is advisable to pick a couple of them and simulate them for real. This will allow to verify monitoring actually works as expected and runbooks contain all the correct steps. While monitoring allows us to react fast in case of incidents, it is usually quite limited in terms of the data we can pass, as well as data retention time. For these scenarios, we are using logging. It usually has a lot higher data retention capacity, which is helpful during trend analysis and incident investigation. It is important to use structured logging. It doesn't matter which structure to use as long as you're using it consistently. This allows for easy search whenever you need to debug a production issue or assess the results of the experiment or feature rollouts using feature flags. PII stands for Personally Identifiable Information. UGC means user-generated content. Both are a hard no for logging due to potential legal consequences like GDPR. The crux is that oftentimes developers may not realize they may actually be logging that data. For instance, one of the popular misconceptions we used to have among Jira developers is that Jira URL is safe to log. It is not, because it could contain a project key, which is user-generated content. Whenever any of that data gets logged, we have to purge the logs. And that often includes other valuable information that could already exist in the logs. In order to mitigate the risk, we have implemented a separate proxy service that pre-processes the logs and redacts known bad patterns. For example, all the logs that contain an A commercial sign are getting redacted in Jira, as in the phrase that contains A commercial gets replaced with asterisks. Data ownership is something we learned the hard way. Whenever you have a lot of products and teams sharing logging pipeline, at some point you will go over the contract limits. At that moment, it is crucial to know who produces too many logs. This will allow you to reach out to those people and ask them to adjust their logging strategy or completely turn off the logging capabilities for them until they actually do that. It also allows you to monitor the trends and proactively reach out to log owners in case you see that they're trending up and they could potentially be producing too many logs. At Atlassian, we follow you build it, you run it approach. This means every team works on supporting the feature all the way through its lifetime, from the design and implementation to release to production and making sure that it works as intended. This includes defining service level objectives, running a 24/7 on-call roster schedule, and the regular tech ops meetings. SLOs are usually defined based on existing monitoring. Whenever SLO is breached or is close to being breached, fixing it becomes the highest priority for the team. On-call roster schedule assumes a person on shift will be able to respond to the page within 15 minutes of the page. Once a person is paged, they are expected to mitigate the issue using the runbooks, which is why it's important to send the runbook link as a part of an alert. If mitigation is not possible, the person on call is expected to escalate the issue higher up until we involve enough people with enough knowledge to get the issue resolved. Tech ops meetings are usually held at the end of on-call shifts and allow the team to reflect on the shift results. We analyze recent alerts, trends, and incidents. Tech ops actions usually are related to improving alert reliability and addressing negative trends before it's too late to do. These are some of the learnings that we found on the way of converting a testing pyramid into a testing hourglass. I hope they could save you some time and help expand your testing strategy beyond the testing pyramid. Thank you.
So let's take some questions. So first one, why did you choose Flow over TypeScript for type checking?
Oh, that's a controversial one. In fact, we chose Flow over TypeScript about 3 years ago when Jira Frontend was just starting to be a thing, when we started our migration to React. Back then, it wasn't that obvious which one is going to win. And Flow was realistically providing a better type checking back then. So we chose Flow. Over time, we were writing code in Flow, and right now we have approximately 2.5 million lines of code, most of them which are Flow typed. And it's really hard to transition into TypeScript nowadays. However, we have actually started to investigate that possibility. Probably half a year ago, other teams and products at Atlassian started to migrate towards TypeScript. And right now we are checking what it takes to perform a migration. The issue with the migration is that, once again, we have a huge code base. It's quite important to make sure that we are migrating it gradually and not in a big bang fashion. Because if you're migrating into a big bang fashion, you are potentially blocking a lot of developers and blocking the release of any features. So this is actually something that we are working towards to in the upcoming year. But right now, the state is we picked Flow when it wasn't that obvious who is going to win that war. And right now, we are actively seeking to reevaluate that choice and come up with the strategies of migrating to TypeScript or significantly improving existing Flow type checking.
So next question, what is the attitude towards tracing at Jira, and do you use it?
That's a great question. Once again, we do have separation between the backend and the front end. We are already using tracing on the backend, and that provides you a lot of great insights. That is definitely something that we want to use. So it stands somewhere between monitoring and logging. In Jira frontend, we don't have tracing just yet, but we're already investigating that possibility. Essentially, the idea behind tracing is to pass a particular ID across the whole request. Whenever, essentially, what happens between when a customer makes an action and performs an action, and that action gets reflected on their screen, which is usually a bunch of front-end interactions, a request to the backend, the response back to the front end, and a bunch of other interactions on the front end. So we have the backend part covered. Right now, we are investigating what would it take to actually introduce tracing in the front end. What that will give us is the capability to see the whole flow of interactions between front end pieces and backend pieces and back as a response to customer interactions, and that will give you huge insights. What is happening? Where could you see the bottlenecks? What are the unexpected behaviors that you could identify? This does give us a lot of insights in the backend, and we do plan to introduce it in frontend. Definitely 100% in favor of introducing tracing in the frontend.
So earlier in your presentation, you discussed the use of feature flags for feature delivery. Which feature flag values do you use in the tests?
Oh, that's another controversial question. Originally, we had a separate set of feature flags for testing environment. And the assumption was that developers, whenever they're developing a feature, at some point they'll flip the feature flag toggle in test environment first, and the test will automatically start using that new feature flag. And then eventually, once the feature gets deployed to production, they will toggle that feature flag in staging and later in production. What happened is, first of all, feature flags are usually supplied by a third-party service. What that means for the unit test is that you have another variable, and that essentially makes your unit tests less reproducible. As in, your test could fail because of a feature flag. Someone could turn feature flag on or off, like toggle them, and then you rerun your tests and they will pass. And the input in terms of code is exactly the same. So having that third-party location for feature flags made our tests a lot more fragile, and made us uncertain about what happens. One of the solutions we were thinking is maybe we need to dump all the feature flags that we're using as a part of an artifact for the build, and that will allow people to replicate the issues. That also proved out to be quite a tedious process. What we ended up doing is, right now, whenever someone introduces a feature flag in the tests, it is always assumed to be true. Essentially, people introducing the feature flag with a particular functionality, and that functionality turns the feature flag on all tests. Essentially, whenever you're introducing a feature flag, it's already on in all the tests. That's how we approach it. And then eventually people will toggle the feature in staging and production and so forth. As you can imagine, this doesn't test all possible combinations of feature flags, and we accept that risk. We do tests using post-deployment verification. We do have comprehensive monitoring that allows us to identify if we do have issues in production. What we do in frontend, oftentimes, if people worry a lot and if the functionality that they're testing is quite crucial to get right, they would test for both values of the feature flag. Once again, we don't do that all the time, simply because there's so many different combinations of feature flags that you could have. If you're testing one feature flag, it's fine. You may be testing two feature flags, but whenever the number of feature flags in your code grows up, you are getting an expansion number of feature flag combinations, and it's just not feasible to do that. So in case people are testing both values for feature flag, what would happen is usually these are short-lived feature flags. I think people will deliver the feature flag, make sure that everything works well in production, and remove feature flag, and subsequently remove an extra set of tests that are testing for the old version of the feature flag. So this is the approach we are taking. Essentially, if you are modifying something that is crucial importance, you probably want to test for both values of feature flag. Otherwise, we are usually relying on post-deployment verifications and on monitoring in production.
So we got a question on how frequent is your release and deployment cycle?
All right, so my team actually has release cycle as our SLO. What we call release cycle is 3 parts. Whenever a developer commits changes into a branch, we are running a branch build. Once they merge their changes into master, we are running a master build. And then once master build succeeds, we're producing deployment artifacts and we're deploying it to production. So the SLO we have is a combination of those 3 values. We are calculating 90th percentile of branch builds. We are calculating 90th percentile of the time it takes to build master build. And we are calculating 90th percentile of the time it takes to deploy release to the first production instance. So this time in total is my team's SLO. Right now, we are hovering between 70 and 80 minutes. That means assuming that developer commits all the changes into their branch and they get the PR approved instantaneously, it will take 70 to 80 minutes for the developer's changes to land on the first production instance. So our with that definition, our release cycle is 70 to 80 minutes. Every day we are releasing 6 times a day, and these are gradual releases. So we start with staging, we soak in staging, then we release to first production instance, first production environment, which is a lot of instances, then a second production environment, and the third production environment. The deployment time is approximately 3 hours because we are soaking 1 hour in staging, we're soaking 1 hour in the first production environment, which is a small one, then we're soaking another hour in the second production environment, which is a bit larger, and then we're deploying it. Only then we're deploying to the largest production environment that we have. So in terms of the release, the time it takes to deploy stuff from staging to all production, we're talking approximately 3, maybe 4 hours, because the deployment process itself takes some extra time as well.
So we are out of time, but we have 2 quick questions that, if it's okay, I want to get to. So the first one, how did you implement gradual rollout?
Oh, that's an interesting question. So right now, the way we're implementing it is by using a combination of Bamboo scheduled jobs and a separate JavaScript CLI. So what happens is we have, for every environment, we have a separate scheduled Bamboo job that runs every hour. So that gives us that soaking time of 1 hour. Then what the job does is it runs our CLI. The CLI reaches out into Bamboo and checks what are the recent deployments to the previous environment. So we are looking for all the deployments that were deployed and that have soaked for at least 1 hour. We are also checking that these are not broken deployments, because what could happen is we might potentially have a broken deployment that we had to roll back, for instance, from production. So we are discarding those. So we are taking good, correct deployments and taking the newest of them that has soaked enough in the previous stage, enough being 1 hour. Once we identify that deployment, we make a REST API call to Bamboo to promote this deployment to the next production environment, and also to include canary instances there. That is pretty much how we have it orchestrated. Right now, this works good enough for us. However, going forward, we're already looking at using Spinnaker to do the whole orchestration for us.
And last question, with packed test, how do backend developers introduce breaking API changes?
So with packed tests, the important bit to understand is we have the expectations from the API consumers. And API consumers may not be using all the APIs that API producers produce. So, and given you have packed broker information with all the expectations information, you could actually figure out what are the expectations that frontend has. If frontend or other consumers do not use certain APIs, well, you can just break them and do whatever with them. If they use the APIs that you want to break, what you can do is you proactively reach out to your consumers and you ask them to migrate to the new APIs that you're probably providing them. As they migrate, you have two options to track the migration process. First of all, you have monitoring for your own APIs. And based on monitoring and logging, you can figure out if certain APIs that you intend to break is being used. Once it's not used, second part is to check if packed broker still contains those assumptions and expectations from the API consumers. If it does contain those assumptions, then you still have to reach out to the front-end developers who produce those assumptions and ask them to remove those assumptions, because based on your monitoring and logging, you can confirm that they're no longer using those APIs. Once they remove those assumptions and upload the new expectations to packed broker, well, you are now back into the original situation when you have an API that is no longer used by any customers. And at that point, you can actually implement any breaking changes there. Another option is to provide versions for your APIs. So let's say you're using version 1, you can introduce version 2, which is obviously not used, and you can do completely different API. That's a separate option how you can do that. The issue is, well, definitely you want to persuade your consumers to migrate from version 1 to version 2. And the same idea, once everyone migrates to version 2, you're probably going to remove version 1 APIs. So this is the way we're introducing breaking changes in our REST APIs.
So yeah, we are unfortunately not only that this is all the time that we have for today, we also went a bit over. So thank you, Alexei, for accommodating that, and for everyone that stayed on. So I want to thank everyone that joined us for this live session. And of course, I want to thank our speakers, David Corbett from Pushpay and Alexei Bakov from Atlassian. And before I let Alexei and I think David is also here. So before I let them say their goodbyes, I want to remind you that the link to the recording of the session will be emailed to you by end of day Monday. And I hope to see you at all at our next event. So thank you.
Thank you so much, folks, for coming to this presentation. I hope that helped you learn something useful and important. I wish you all the best and take care. See you.
Yeah, thanks everyone. It's been great. And thank you, Alexei. That was a great talk as well. So all the best. See you later.